Welcome to the Biology 182 lecture on population ecology, focusing on human population growth. In this video, students will learn how to describe what an ecological footprint is, as well as to explain how changes in age and fertility impact human populations. So what is a population? A population is one type of species living in an area. The human population are all the humans living on Earth. We want to understand that population growth is simply an increase to the number of individuals in a population. So for humans, that's just the increase in the number of humans living on Earth. The growth rate is a percent change per year that occurs within the number of individuals in a population. So for humans, the percentage of increase or decrease in population size every year. When we look at this as a graph, we can see that from about 10,000 BCE, which is before the Common Era that we're in now, through about 2019, which was about a year and a half ago, we are at 7.7 billion individuals living on Earth. Around 10,000 BCE, we see there were about 4 million individuals on the planet. Before 10,000 BCE, there were about 1 million individuals or less on the planet. Typically, we've seen over the last 11,700 years an increase annually of 0.04% in our population. Between the years of 1800 and 2019, which is 219 years, we have seen a vast increase in the amount of growth in the population. Our population growth rate peaked in 1963 at about 2.2% increase. We have decreased since then, and our typical increase per year is just over 1%. When we look at the world population growth, we see huge increases over time. And when we look and study these increases, we can see what things adjust the population and allows it to grow. So from about 10,000 BCE through about 5,000 BCE, we were semi-nomadic. But as the era of the city-states began and went from about 4,500 or so BCE through about 500 BCE, we can see there was a huge increase in irrigation with agriculture. We can see we added the wheel, and we found additional ways to help with farming by using wooden plows. In addition, using kiln-fired pottery and bricks. This gave us more permanent fixtures and allowed us to be able to have cooking and water transportation materials. Then in the era of empires, we see definitely a huge increase in things like iron weapons, a metal edge plow, water and windmills. And then we do see some dips, and those are from major epidemics. As well, in the 1860s, which would be the global era, we see aseptic technique. So now we have a huge increase because of the modern age of medicine, in addition to having oil and gas, electricity, coal usage, and steam engines. These are all important factors that allow the population to continue to increase. Here we can see that the population growth peaked in 63 at 2.2%, and the Great Leap Forward famine came in China, where there was a huge dip because it reduced the population from between 1958 and 61 by 30 million people. As well, there was the bubonic plague, which killed about 300 million people before, right in the 1800s. So we see that there are times when we do see major dips in the population. However, over time, we've consistently been increasing. And up until around 2015, we were still increasing, but now we are decreasing our population by about 1% per year. So about 1 million people a year. But we were growing at a much higher rate than that. We're only decreasing the amount of growth by about 1% a year. This is a nice graph because it shows us not only the percentage of growth, but also the population with regard to the percentage of growth. So if we're looking at the world population percent growth around 1700, we had about 600 million people, and our growth rate was about 0.04%, right? That was from about 10,000 BCE all the way through 1700 CE, or in the current era. As our increase in percent of growth rate jumps up, we can see our population tremendously increases as well. In 2019, we hit a decline of 1.08% as our growth rate, but we already have 7.7 billion people. And what they believe is by 2100, we should start to see a plateau, and that we will start to reach our carrying capacity, which we'll talk about in a few minutes. As we reach that plateau, our growth rate will become linear. Some of the other interesting things to note are what parts of the world contribute to this population growth. So from 1800 to 2019, that 219 years, we see that China and India have tremendous population and huge growth. In fact, India will soon surpass China in the number of people on Earth in their country. We do see that the United States also plays a factor, but on a much smaller scale than things like India and China. We look over at the next graph with world populations by region, and we can see about 60% of the population is based in Asia. So our smaller account, only 40% of the rest of the population is found throughout the rest of the world. And a huge portion of that is going to be found in Africa. So as we look, yes, North America is a factor, but in terms of population growth and number of people, we are not quite as heavily populated as other parts of the world. So what things can affect population size? First, we see life expectancy, also the infant child mortality rate, fertility rate, and age structure. So if we look at life expectancy, there are some things that change tremendously from pre-modern worlds where it was very poor and people lived about 30 years to now in 2019 in Central African Republic, people lived about 53 years, but in Japan, 83 years, and that's an average. That doesn't even count the highs in those statistics, just in the average. This is due to the Age of Enlightenment, mass amounts of industry, as well as advancement in technology. It includes major innovation and inventions. We see the Industrial Revolution and, most importantly, modern medicine all playing into this. Life expectancy in the 1900s was very, very different than what we see today. All the grayed out areas, they didn't even have data on. United States, average life expectancy was about 40 to 45, maybe 50 years. When we look at South America, it was like 30 to 40 years. Central America, same. When we look at Europe, we see somewhere between 40 and 50 years. And then in Asia, somewhere between 30 and 40 years. But when we look at 1940, there was a huge shift, and that was only 40 years. Now we have all the data that we can compare. And we see that in Africa, it's still 30 to 40 years in most cases. Maximum, we're looking at 45 in very few areas, 50 years, right? Same when we look at South America and Central America, we're still around 35 to 40 years of age, life expectancy. There are parts of Southern South America that will see them living up to 60 years, and tiny little snippets way up at the top in the northern part. Typically in the United States, we were living about 65 years. And then when we look at Australia, they had it going. They were living about 70 years. Europe, still a little higher, around 65, 70, although some areas were closer to about 50 years. And then most of Asia was around 40 to 50 years. Today, it's totally different, right? The average life expectancy in Africa has changed drastically, and now we see it ranging from 55 to 80 years. Further south is around 65, maybe 70 years. Further north, we hit a little bit more into that 75, 80-year range, but there are still some areas in Central Africa that are only living about 55 years. In Asia, this is where a huge impact changes. Now they're living 75 or 80 years. And in Australia and Canada and parts of Europe, even up to 85 years as an average life expectancy. The United States, Central America, and most of South America is hitting around 80 years. Some around, 75 and some up to 85. Overall, when we think about life expectancy, we have to factor in child mortality and infant mortality. And infant mortality is about deaths from birth to just under 12 months old. And child mortality is age 5 and under, so 1 to 5. And as terrible as this is to think about, globally, this is a huge deal. In the 1800s, about 43% of children died by the age of 5. In the 50s, it was down to about 22.5%. And in 2015, it was about 4.5%. Now that is worldwide. When we look at the United States, right now, we're at almost nothing. I think we're at like around a 0.05% or something like that. So our infant mortality and child mortality is substantially lower, but when we look at Africa, we are still seeing numbers in the teens and 20s. Tons of people having children 5 and under that are dying just based on pneumonia, neonatal disorders, preterm births, diarrheal disease, and most prevalent in Africa, malaria. One thing that attributes to child mortality also can be maternal death due to birth and pregnancy complications. And so we look at that as well, where throughout most of the world, we see a very negligible amount, 4,000 or less, but even lower in first world countries. When we look at parts of Africa and even parts of Asia, we can see there are places where it is still high. China, Afghanistan, Pakistan, India, the Congo, Nigeria, Ethiopia, Tanzania. These are all major areas that are having high rates of maternal death. So when we look at these areas, the 3 darkest or most prominent are going to be India, the Congo, and Nigeria. 2 are in Africa, but India is in Asia. Of the 3 of the teal color, we see Pakistan, Ethiopia, and Tanzania. Again, 2 in Africa, 1 in Asia. Aside from Indonesia and China, we also see smaller countries like Afghanistan, all in Asia, and the rest of the countries are again in Africa. So the hugest areas with complications to life expectancy, child mortality, maternal death are all going to be centralized in Africa and some of Southern Asia. The next factor we look at is fertility rate, which is also called TFR. Fertility rate is the average number of births per woman in the world, per woman who is of reproductive age. In the pre-modern era, we saw people having about 7, 8, 9 children. And so we averaged about 4.5 to 7 children per woman. The mortality 5 and under was so large that people were having massive numbers of children because so many were dying before they were 5. And this young age mortality kept the population growth in check. Today, we are at about just under 2.5 children per woman throughout the world. This is because of societal empowerment and relationship empowerment for women, women's entering the labor force, and advanced education for women. If we could keep the population at around fertility rate around 2% in the population of children per woman, we would have a population that would stay very consistent. The book usually tells you around 2.2 or 2.3%, but the closer we are to 2%, the more sustainable the population will be. If we look at the fertility rates in 1970, we can see that even in North America and in parts of Northern Asia and Europe and Australia, we were at the 2 to 3 child range. But massively in Southern Asia and Africa, we were looking at 6 to 8 children easily per woman. So when we look at this compared to today, northern parts of North America, the eastern part and very western southern edge of South America, Australia, and most of Europe and Asia are around 1 to 2 children per woman. All of the light blue is going to be about 2 to 3 children. So those areas of the world are doing well with keeping our number of children per woman, our fertility rate, low. However, so much of Africa is so much higher still that it's carrying so much of the population there of the world. And so when we look at this, we're seeing huge areas that are having 4, 5, 6, 7 children per woman. Another thing we look at is age structure, and this is a little more challenging to understand. Some of the graphs look like those needlepoint, or they're called pyramid graphs. And that's real traditional when we look at the pre-modern world, and even the early 18 and 1900s, we can see a lot of those pyramid style graphs. In 1950, we had about 20% of children that were dying before age 5 still worldwide, where today 0.05% of children are dying before age 5 where we are. So it's definitely a huge difference in the population as we're having longer life expectancy due to a better healthcare system and less children dying. So instead of seeing this sharp point now, we're looking at a more squared out graph image. And this is more of a healthy population. You have a low risk of death at a young age and a very high chance of old age probability. And so this is what we're starting to see, this more box shape. Another interesting way to look at the data is by looking at a comparison between a select group in Nigeria and Africa, which has a low life expectancy and a high child mortality rate, and Japan, which has a high life expectancy and a low child mortality rate. When we look at Nigeria, we can see the deaths in children, or the population, sorry, of children under 5, right? And we look at the population about 5 to 14 years and 15 to 24 years. Well, that weight makes up the majority of their population. Then comes their 25 to 64-year-olds. And then 65 and older is almost nothing, right? So people aren't really living past 64 here. Where if we look at Japan, the number under 5 is very minimal. That is closer related to the 65 and older gap in Nigeria. 5 to 14, still very low. 15 to 24, pretty low as well. It's not until we jumped 25 to 64 years that we see this huge population increase. And that's the workforce. And then 65 and older is about the same as 24 and younger. So as we're looking at these populations, we can see populations that have more first world advantages also include having a larger age structure than first world countries. Another thing we're looking at here is that working age. And so in Japan, there are tons of individuals in this working age. And that hump you see was like the baby booms, right? When we had the baby boom and there was all of a sudden all these people who were having babies, we see a bump in the number of young and then a bump in the working age, right? And then we even see a bump now in the elderly because those people had to grow up. Where when we look at Nigeria, they didn't have a bump. They've had a steady increase. And right now, their young and their working age are large and their elderly are getting there. But as these working age continue to increase, their elderly will begin to increase as well. However, if their life expectancy doesn't increase, it won't change much from where it is today. This is why sustainability focuses so much of their efforts on trying to improve living conditions around the world. So what's a carrying capacity? The carrying capacity is simply the maximum population that any environment can sustain. So if you look at the fishbowl, right, those fish, goldfish, happily swimming, whoop, whoop. But in the left, it's like way overpopulation. Now they're running out of resources, people are dying off, right? We look at this quote by Gandhi when we think about the earth. Gandhi said that the world is big enough to satisfy everyone's needs, but will always be too small to satisfy everyone's greed. So what is he talking about here? He's saying that the average human right now needs about 3 hectares of productive land to support the damage that we're doing to the environment. 3 hectares. Americans use about 10 hectares. So our first world country, ours, is increasing the amount of negativity in the world because there's not enough of the productive land to support the life we live. Now, there are other first world countries like China that have an average of 1 hectare or 2 hectares, even India. Now, their populations are much larger, but they have far less area than we do as well. So this is why we start looking at our carbon footprint. And a carbon footprint is the amount of productive land needed to support a person during their lifetime. So what do we use land for? Crops, wood, fossil fuels, minerals, right? Land to build things. Our highest usage comes from energy, food, and forestry. So energy, building, and eating, right? If we look at this, the Earth has 12.2 billion hectares of usable, biologically productive water and land. We know there's 7.7 billion people on the planet. That's less than 2 hectares per person. We have to lower our impact on the Earth drastically if we are ever going to continue to leave an environment for our future generations. So what do we take into account when looking at the amount of productive land needed? That's forest land, right? Land to rebuild our forests that we keep cutting down to make wood, to build. Energy land, which is going to be land that we use to eat up our carbon dioxide emissions. And so that energy land is so important. And we keep, again, cutting down our trees and getting rid of so much of the agriculture, plant life in the world. Grazing land. This is for cattle, sheep, any kind of ranching that we're doing, right? And for organisms who live in the wild, in savannas, all over the world. Also cropland, right? We need food. We have to be able to grow crops to be able to support the people of the world. Then we have built up land and fishing ground. And fishing ground also includes the water usage needed for like sea life as well. So we can look at this as the need for bioproductive land to make wood, bioproductive sea to make food, and bioproductive land to make food as well. We also need energy land to make food and for travel. And we would use energy land for travel, for waste, for food. We would use energy land for energy, right? And then also built land for waste and travel, for us to live places, right? And then we need land for biodiversity. We need to keep this planet alive. So what is sustainability? Sustainability is the ability for the earth and humans to coexist. In order to do this, we need to achieve a biological balance. This is a balance between the human population, natural resources, and the future. The natural resources are going to include the other organisms on the planet that keep the planet existing, right? That keep the ecosystems in harmony. The UN states that the sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. When we think back to Gandhi, there is a huge difference between need and greed. We need to look at what we need and not what we want, right? In order to increase the sustainability of the earth, we need to stop thinking of only ourselves. It's more than looking at the environment and our population and our natural resources, but also eliminating poverty will go a huge way to create biological balance. No hunger, good health and well-being, quality education, gender equality, clean water and sanitation, affordable clean energy, work and economic growth, industry, innovation, and infrastructure, reduced inequality all the way around, sustainable cities and communities, responsible consumption and production, climate attention and action, paying attention to the life below water and life on land, as well as peace, justice, and strong institutions. When we look at these things as a partnership, we may finally be able to have a biological balance of our population with the natural resources while still allowing future generations to continue to exist on Earth. At the end of this video, students should be able to describe the impact of age and fertility rates on population growth, and they should understand how to determine the impact of an ecological footprint.